Okay, so this will be the implementation for the hashing or direct search that I've actually given to you before in the other video that with the description and other steps as well as the um, time and space complexity event. So in this structures right now, I'll be going to illustrate to you how does it work in a step-by-step manner. We'll be going to go ahead and step-by-step the process we do have there the 15, 26, 34, 12, 78, 69, 87, 48, 59, 63, 10, 71. All you do have to do right now, you will be going to perform the insertion first before you will be going to deal with the searching. So say for example, you will be going to search later on. I want you to search the um search 10 and then you will also search I want you to perform searching with 34 and then 87. So there will be three major elements that you will begin to search later. So for this one right now, since we don't have yet a hash table in this function, this is the array, given array that I wanted you to illustrate with the hash and then you will insert this into the hash tables and everything. So we do have here right now at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 array element in our array that was given right there. So as what we have mentioned, we do have the hash table size and that is equals to 10. So in your case, since there will be a table of 10, so your table is set to have a 10 elements in that figure. That is to say, you cannot insert another element in that given hash table if that is full. So what you will begin to do if that is not if you are not working with expansion with the hash table, therefore you will begin to return after you were able to handle the linear probing, you can definitely return that the hash table is already full. Because you cannot also state here that the hash table is already full by assessing by checking that one in the figures that you were able to see here, but you have to step by step the process as what being mentioned, i-step by the step para sumakses. So now we'll begin to start with. Now, in the step one, this will be the implementation that you will begin to do. Since in your step one right now, there will be a element of 15. So insert 15. So how will you be going to work on the insertion with that? We will begin to use the hash function as your formula stated right there that the hash key is equal to the key modulo of 10. That means to say, what will be the remainder of the division? That will be the index number that you will be going to insert that value. Now here then. So suppose that you have the 15, so the hash key for that one, say for example, the hash of 15, you will divide that step by step 10 divided by, no, that is not 10. 15 divided by, I'm so sorry then, okay, 10. And that is 1. So what is the modulo? Modulo of 10. The remainder is 5. Since 10, we do have a remainder of 5. 1, then remainder is 5. So therefore, your modulo right now is 5. So how will you be going to place this in the specific hash table? So your hash table right now, suppose that you only do have 10 size. So that will be, you will insert that in the 5 index. So it will be 15 here. That's how you will deal with that in the step-by-step manner. And in the step 2, it will be here, insert 26. Now, in this case as well, you have to get the hash value of 26. So 26 divided by 10. Why we will be going to divide it into 10? Because the 10 is your hash table size. That's how you will be going to organize that one. So if you will be going to divide 26 over 10, that will be 2 remainder of 6. Remainder 6. Therefore, your 26 modulo of 10 is definitely 6. So we will insert that, update that in your table, hash table, as we do have a 10 on specific address. So update 15, then it will be 26 here. Now, step 3. The step 3, that will be, we're done with this, we're done with that. So that will be 34. Insert 34. So what will be the hash function of 34? Hash value rather. So what we're going to do here, 34 divided by 10. That is basically 3. And I'm so sorry. Remainder of 4. So therefore, right now, the 34 modulo of 10, that is 4. So what you will have to do, you have to insert your hash table right now. Okay, therefore it's like that already. So you will begin to insert that in your index 4. As we have earlier, 15 is in 5, and we have 26 in 6. So insert 34 in 4. That's how you will deal with that. And you will be going to proceed. I'm so sorry. This is like that. Step 4. For step 4, we're done with the 34. We'll insert 12. Okay. The hash function of 12, hash value, 12 divided by 10, that is 1, remainder of 2. Okay. Therefore, the modulo of 12 of 10 is equals to 2. And we will begin to insert that in index 2. So, update in here, I'm sorry. You have earlier the 34 in 4. You have 15 in 5, and you have 26 and 6. And you will insert 12 in 2. So, it looks like in your implementation. So we're done with 12. We'll insert 78 right now. So insert 78. So what will be the hash value of 78? So 78 divided by 10. It will be 7. What will be the remainder? It will be 8. So therefore, the modulo of 78 of 10, that is 8. So you will update your hash table, insert that 78 in your 8 value hash table. So update everything 26, 15, 34, 12. And in your step 6, what will be the function that is 69? 69, insert 69. And in your 69, the hash value of 69, 69 divided by 10, that is 6, and the remainder of 9. Remainder 9. So 69 modulo of 10, that is definitely 9. And you will insert that in index 9. So 9 right now, that is 69. And your 8 is 78. And 26, 15, 34, and 12. So we're done with the step 6. We will proceed into the step 7, which is in your step 7, and that is 87. So 87 right now, insert 87. The hash value of 87, 87 divided by 10, that is 8, and the remainder of 7. So therefore, the modulo of 87 of 10, that is 7. So insert that in index 7. So you will update the hash table the same thing. So I know that it will be a lot of process class. However, you need to step by step the process of as always, of course. 12 here. And your 87 here then. So in your step 8, right? And 87 to 8, 87. So you will insert 48 right now. Insert 48. So what is the hash value of 48? 48 divided by 10, it will be 4 remainder of 8. And of modulo 48 of 10, that is definitely 8. So you will insert that in 8. So since 8 was already, there is a index, we call this one, your index 8 was already taken. So you cannot insert, you can definitely put right now 8, index 8 is taken. So you can definitely put as basis for that one. Or for example, in order for us to, yeah, that must be that you will begin to deal with. You will not ask that in index 8, is it um taken or not? No, no. It must be like this. This will be the update so that we could be easily work on this software, okay? So index 8 is taken, so linear probe next, like that. Index 9, so dili ka na, this will be the case that you will begin to compare already in your index 9. You will just be going to figure out here that index 9, you can definitely put as well index 9 is taken. So we will be going to do probe next. So the next will be the index 0. Index 0 is available. So insert 48. So what will happen? 48, and then 12 here, and 34, 15, 26, 87, 78, and 69. So that's how it works, class. In our class, it's different implementation that we've mentioned because we were able to identify there that index 7, is it empty or whatever? No, you identify Prognax. But here, we'll just state directly that index 8 is taken, index 9 is available or whatever, so that it will be easy for you to implement them, so that we will begin to have the same answer, okay? Get it? Hopefully that is clear to everybody. And for the step 9 class, step 9 here, since we are done reading 48, what will happen? We'll insert 59 right now. 59. Insert 59. So the hash value of 59, 59 divided by 10, that is, excuse me, 5 remainder of 9. So update everything into your hash table. Okay, update earlier, 48 here, 12 here, 34 here, 15, then 26 and 87, 78, then 69. So what will happen right now? Since index 9 is taken, index 9 is taken, probe next. Since we're dealing with the linear probing, so it must be step by step that you will begin to compare with. So index 0 is your next index to be checked. So index 0 is taken as well. So probe next. So index 1 is available. Available. So insert 59. So we'll have an update here, 59. So that's how you will work on that one, okay? Always remember that you will begin to deal with that in step-by-step manner. And in the step 10, since we're able to have it in here, 63. So insert 63 in your table. Insert 63. So what you will begin to do, the same implementation, 63 divided by the hash value of 63 is equals to, divided by 10 is equals to 6, the remainder of 3. Remainder of 3. So update your hash table. So your hash table earlier is that is 48, 59, then 12, and then 34, then 15, 26, 8, 7, 70. Oh my God, that's my bad. So my application is not working yet to actually back down. So that just give me a second, a little bit here. It is somewhat not working. It's not participating right now. Just a moment, a little bit. Okay, I'm so sorry with that one. There's something wrong with my application. So the step 10 earlier, we do have a remainder of 3. And since 3 earlier is actually available, so we can definitely insert 63 right there already. So since we're done with the insertion of 63, so we do have here the 11th element, which is the 10. So what you will be going to do right now, insert 10. Although that is full already, but you cannot identify that if that those are available if without checking each one of the hash table. So we need to step by step the process still the same thing. So right now the calculations for that then is definitely, I'm so sorry, in your step earlier you do have something wrong because you were not able to identify the modulo. I forgot it. Okay, let me fix that one moment. Okay. All right. So, comma will be there. All right. So for this one right now, 63, the modulo of 63 of 10, that is 3. So that's why we'll insert that here then. So that's how you will deal with that. So we're done with that. We'll begin to insert 10 already right now. So what is the modulo of 10? The hash value of 10, that is 10 divided by 10, that is 1. Excuse me. 1 remainder 0. So therefore, the modulo of 10 of 10, that is 0. So we'll begin to check one by one if the hash table, if we can still insert that element given that if you will begin to check right now while you will begin to identify that already in our array. I mean, hash table is already for a full. However, we need to do this step by step checking manually as always. So now, index 0 is taken. Probe next. Okay, index 1 is taken. Probe next. This is the thing that you will deal with. Index 2 is taken. Probe next. Index 3 is taken. Probe next. Then index 4 is taken. Probe next. And then index 5 is taken. Probe next. And index 6 is taken. Probe next. Index 7 is taken. Probe next. Index 8 is taken. Probe next. Index 9 is taken. So since that is the last, right now, what you will need to do, hash table. Hash table is full. Okay, that's how they so cannot insert 10. Okay, so you cannot insert 10 already in your hash table because that is definitely full. Right now, plus 71, you will begin to deal with the same thing, the same that you will begin to search, check up until index 0 for that one. However, right now we need to just remove that one because we will deal with a searching already so that we could be able to lessen the time. So we're done with the insertion. So we'll begin to search 10 right now. Okay. So your updated element, this is the updated element. So we'll just copy that one. Okay. This is your hash table. This will be the basis that you will begin to deal with in the searching. So we'll begin to search that manually. No. All right, now search them. Okay. So for searching, you will begin to divide the same thing. The step follow. 10 is divided into 10, and then equals 1, remainder 0, remainder 0. 10 modulo of 10, that is 0. Okay, you will begin to identify 10, is it equals, no. Index 0, is it equals, no. Index 0, which is 48, is it equals to 0? No. Probe next. It must be like that. Index 1, what is index 1? That is, let me check if that's 69. That is 69. Is it equals to? I don't know. 10. Is it equals to 10 here? Is it equals to 10? No. Probe next. And right now, index 2. What is your index 2? Index 2 is 12. Is it equals to 10? No, still. Probe next. And index 3. What is your index 3? That is 63. So is it equals to 10? No. Probe next. Okay. So we'll begin to check index 4. What is index 4? That is 34. So is it equals to 10? No. Probe next. Index 5. What is index 5? 15. So is it plus the 10? No. Probe next. Index 6. What is index 6? That is 26. Is it equals to 10? No. Probe next. Index 7. What is index 7? That is 70. Index 7 is 7. Let me check. Or do we have 7 here? Okay, that is 87, I think. Right? Yeah, 87. 87, 87, 87. Why is it 7 earlier? Okay, that's 87, okay? We're not able to put here. Okay, that is 87. Is it equals to 10? No. Probe next. Index 8. What is index 8? That is 78. So for the index 8, is it equals to 10? No. Probe next. Afterwards, I'm so sorry, that went up. So that's how we will begin to deal with. I know that it is really taking a lot of time for you, but um, it will take a lot of process actually. But you don't have to worry about that. You can definitely do it. So index 8 is it equals to 10. So index 8, we can just, well, is it equals to 10? No, probe next. Sorry, no penmanship. Index 9, but you can definitely understand that one if you were able to listen with my with the whole video. Is that equals to 10? No, probe next. No. So you will begin to just stop right there. Then you will begin to 10 is not in the hash table. So you will begin to see put here 10 is not found. Okay. All right, so since we're done with that, as we go, we're done with the search, then we'll search 34. 34. Yes, 34 is that right? Yeah. So for this one right now, what will be the hash value of 34 divided by 10? That is 3 remainder of 4. So 34 modulo of 10, that is 4. So index 4. What is index 4? Index 4, that is 34. Oh, no. Search here. It's not index. Okay. Is that equals to 34? Yes. 34 is found at index 4. Now, you have to search another. We're done with the 34. The next will be 87. Search 87. 87 divide 10 is 8. Remainder 7. And 87. 87 modulo of 10. That is 7. So what is index 7? Index 7 is equals to 87. Is it equals to 87? Yes, definitely. So what you'll begin to do, 87 is found out 10, index 7. So that's how you will begin to deal with that one. Yes, you have to step by step the process. If you were not able to find that in one search, you will begin to do the implementation as always. You will begin to definitely perform the linear probing until you could somewhat find that element. Okay, so we're done with the this hashing. So I want you to perform the hashing, searching as well as the insertion for in this case. So make sure to study with this implementation, okay, because it will really um be there in our examination. So thank you so much everyone and have a great day. And I'll begin to record another video for another search algorithm as well. See you in there.